Completing the square all comes down to this concept of the perfect square. So, the perfect square is when you have two things added together that when you multiply them create a perfect square. So here I have two things. I have a plus b and a plus b. So I know I could label these sides a and b to represent my long and short lengths. So that's like saying I've got two brackets. And then if I find the area of each of these little rectangles or squares, I could tell you what the big area is. The big area would be a squared plus 2 lots of ab plus b squared. So that's what's actually happening when I'm talking about a perfect square. I'm talking about two things multiplying together to give me an area of a square. So they must be identical. And so our solution comes out as this. We can do that with anything so long as we have identical brackets. And we're just using FOIL. So first to first, middle to middle, outside to outside, which will get us 2 lots of negative AB, and then plus B squared. And this one, we've got x squared plus 4x plus 4. Alright, so that's just expanding. You can do that in your sleep. 3E, 105, question 1. But now we want to think about these perfect squares and how they've expanded. If you did all of the ones in question 1, you should notice that the sign in your bracket matches the first sign in your expansion. See? Negative, negative, positive, positive. And our last sign is always a positive. Okay, that's important. These are my general expansions. So a plus b squared is a squared plus 2ab plus b squared, and the other one with a negative. What this is saying is that we've got a perfect square if the first and last terms are squares and the middle term is 2 lots of the square root of the first times the square root of the last. So we want to be able to identify that. So here I have something squared plus 2 lots of 3 times x plus something squared. So you can see I've got these two numbers both in my middle term times by 2. So that is a perfect square. So to factorize it, I can use the cross method or whatever method I've been using. But to factorize this one by recognition, I've got an x, I've got a 3, and that sign just drops straight down in. Squared. Done. Alright, sometimes you can take out a common factor, sometimes you can't, sometimes they're more complicated. So this one's a little more complicated. So we've got something squared minus 2 lots of 10x plus something squared. So 2x times 5 is 10x, beautiful, I've got that, times by 2, so this is a perfect square. So we take our first term and our last term and drop that sign down. Alright, here this one does have a common factor, which we can technically do it from what we've got right now, but we can also simplify it. If you take out your common factor, you're then doing perfect square for what's left. So we think about this, we've got 2x squared plus 2 lots of 10x plus 5 squared. Once again, 2x times 5 is 10x, good, times 2, beautiful. So this one factorizes out as 2x plus 5 squared. Fantastic. Alright, one last one. We've got something squared minus 2 lots of 9x plus 9 squared. Perfect, we've got our two n terms in the middle, times by 2, so that one comes out as x minus 9 squared. Practicing those here.